Can you hear me? Sugat.
Mr. Chintaka, hello. Mr. Chintaka.
No, I'm Professor Anas here. Sugat.
Yes, okay.
Yeah, actually, you said that you want to check the, the
Presentation, yes.
presentation. Yeah,
Presentation. What
first,
is the
whether
class?
it is, the,
Working
you
or
know,
not?
yeah, working on it. As you are, you know that the transmit this one on, via YouTube. So for the YouTube participants anyway. So did you check that one next? You want to check the technical things first. You need that. You want to check the technical. The technical. That compatibility of the presentation and all these things.
Dr. Dinesha, can you share the presentation? Then we can check whether we can see it or not.
Yeah, I will share.
Yes, good.
Yeah, I'm sharing presentation.
Madam, now. Right, good. Madam, shall we stop it for a while after starting the meeting? Shall we do it?
Well, did you start the YouTube transmission? So did you start the YouTube transmission now?
Yes, doctor.
Yes. Yeah.
YouTube
Yeah, okay.
live is going now.
Oh, did you also join the meeting?
President, shall we start now?
Professor Neil?
Yeah.
Hello? Professor Neil, shall we
Yeah.
wait for about 5 minutes?
Yeah, sure. Okay. No
Because
problem.
you know that statistic is nobody can start from the middle. They have to
Okay.
start. Am I right, Dr. Dinesha? Are you okay with?
Yes, I'm okay. Sir. I'm okay.
Okay, thank you. May baat ka na ilaw ni Dr. Sugat? Dr. Sugat? Dr. Sugat?
Shall we start now?
Yes, right, correct.
Good afternoon to you all. You are welcome to SLVA Scientific Writing and Writing webinar series. This webinar consists of 3 webinars focusing on Sri Lanka Veterinary Association 76th International Scientific Session. This webinar is proposed by Indunil Pathirana, the chairman of the Scientific Committee of Sri Lanka Veterinary Association. Thank you very much, sir, for your valuable proposal. Today, our topic is selecting the right statistical test, practical insight from data analysis. Our resource person is Dr. Dinesha Ambagaspitiya, lecturer, Department of Biochemistry, Faculty of Medicine, University of Peradeniya. Thank you very much, madam, for accepting our invitation today. Our moderator is Professor Neelalas, Professor in Biochemistry, Department of Biochemistry, Faculty of Medicine, University of Peradeniya. Thank you very much for your support for the webinar series, sir. Without getting much time, I would like to invite Dr. Muhammad Ijaz, the President of Sri Lanka Veterinary Association, to welcome you all.
Thank you, Dr. Sugat. On behalf of the Sri Lanka Veterinary Association, I would like to extend my warmest welcome to the first webinar of during my tenure. And during lunch hours, I think I must thank all the participants as well as the resource person and the coordinators of this webinar series, Dr. Sugat, Professor Alas, and Professor Indunil. Thank you all of your inputs. I would like to welcome all of the participants as well as the resource person on behalf of Sri Lanka Veterinary Association. Without taking much time, I would like to hand over the mic again to the Dr. Sugat to continue this proceeding. Thank you.
Thank you very much, dear President. I would like to invite Professor Neelalas to introduce our resource person today. Dear Professor, over to you.
Yeah, thank you, Dr. Sugat. Good afternoon to you all. Good afternoon, President Sir, Dr. Ijaz, and all the EXCO members. Good afternoon, Madam Dinesha, Ambagaspitiya, distinguished participants. The participants actually allow me to introduce my colleague, my collaborator, and my friend, Dr. Dinesha Ambagaspitiya. She's a distinguished alumni of Mahamaya Girls College, Kandy, and I know once achieved the top position in the national level examinations also. Dr. Ambagaspitiya commenced her university education in 2009 and obtained her MBBS degree with distinction in 2015. Following her graduation in 2015, she served as an intern house officer before joining to the Department of Biochemistry, Faculty of Medicine, as a lecturer in December 2016. Then she embarked on her research journey, pursuing an MPhil degree and entered into many research fields. Over the span of 6.5 years, I believe, she has authored 7 peer-reviewed publications, including international original articles, full paper conference publications. Additionally, she has presented 29 abstracts at various conferences, including 7 international ones, and has received 2 first place awards for presentations. Dr. Ambagaspitiya has also contributed as a resource person in 2 workshops already, and resource person in the diploma in exercise and sports science program. And the title of her presentation is Selecting the Right Statistical Test, Practical Insight from Data Analysis. Without further ado, I invite Madam Ambagaspitiya to commence her presentation. Over to you, Madam.
Thank you very much, sir, for that kind, nice introduction. And I consider it as a great honor to be introduced by one of my greatest teacher. And it's because of that I'm talking here today like this. And some of the principles that I will be sharing today were learned from sir as well. So thank you very much again, sir. And wishing good afternoon to all the participants. I'll share my presentation. Yeah, I hope you all can see the screen.
Yeah, we can see it.
Okay.
Yeah. It's
Today's
visible
topic,
and audible also. Clearly audible. Yeah.
Today my topic is selecting the right statistical test, practical insights from data analysis. Difficult task because it's really difficult to talk about all these things within 1 hour. But let's see, I'm going to try my best. So statistics, what is statistics? We all know that it's something to deal with maths. It's something to deal with research. And when you check out the definitions, in most of the places, they're telling that it is where you're going to deal with analyzing of data, organization of data, presentation of data. So it is something to deal with data. But what is the importance of selecting the correct statistical test? So this famous writer, Mark Twain, had included statistics as one of the 3 types of lies, indicating that he himself had real difficulties in understanding the illustrations related to statistics, as well as that if you use this incorrectly, there can be so much destruction that can cause to the world. So therefore, selecting the correct statistical test is something very important. So if a wrong statistical test was selected, we all know that we are going to deal with related to statistics. So therefore, we may end up with misinterpretation of data leading to incorrect conclusions, or it will lead to inefficient resource utilization as well, because you have designed and you have spent your time, resources on conducting this research, and ultimately you find out that you are going with the wrong statistical test, ending up with wrong conclusion. And also, it is something to deal with ethical consideration as well. So therefore, with all of this background, it is really important to know whether you are selecting the correct statistical test or not. So with this background, I'm going to talk about when to consider about the statistical test during your research and the factors that will influence the statistical test selection, and also a brief overview of the common tests that will be used during statistics and some strategies that I practiced by myself as to select the tests. So first question, when to consider about the statistical test during your research? So I'm sure that all of us will agree that there is a part of statistics to do with the results. So results analysis is basically going out with the data, what you're going to do to the data with the statistics. But it's not only at the results analysis that you have to think about the statistical test. From my learning point, and I do believe that the statistical test selection should start from the point of designing of your research question. So once you identify your research question, then you have to think how to answer your research question properly. So I just try to come with some examples. So then I thought, okay, I'm going to talk about concentration of lead poison or something associated with lead poisoning with among the dogs, which related to some effects, adverse effects with related to lead poisoning. So when you're talking about, okay, I'm dealing with lead poisoning and I'm dealing with the lead levels in dogs and some adverse effects with related to that, the first question that came into my mind, what is the lead concentration levels in kidney and liver in dogs? in urban environment. So if I'm talking about this, I'm talking about what is the lead concentration. Nothing to do with much statistical analysis, just a data. But if I'm going to modify it, is there a relationship between the lead concentration in liver and kidney in the dogs? So then I'm going to take two things, and I want to see whether there is a relationship, whether with the increase in the lead concentrations in liver, whether the lead concentration in kidney is also increasing, or whether it decreases. What is the relationship? And the second question that I thought, is there a difference in the levels of lead concentration in liver and kidney in household and stray dogs living in the urban area? So here I'm again looking at with a different perspective. So in the urban area, there can be two groups, stray dogs as well as household dogs. So if I check the lead concentration in liver and kidney of all these dogs, can there be a difference in the lead levels in these two groups? So now we are looking at it in a very different perspective. Earlier, we tried to think about some correlation, relationship, but here we are checking, is there a difference? And moreover, I thought, okay, is there an association between having excess lead concentration in the liver with the prevalence of anemia in household dogs in urban environment? Now I'm confined to household dogs, and I'm trying to think, okay, so in the household dogs, if I assess the lead concentration, and if I can find, okay, there are dogs with excess lead as well as there are dogs with low lead level, normal lead levels, and can it contribute to the development of anemia? So in these three situations, the type of data analysis that we are going to deal with is different. So in the first situation, it's just a correlation that I'm going to look at. So I just want to compare these two groups. But when it comes to the second situation where I'm looking at the differences, so there are so many things that I can check. I can check whether there is a correlation between the household dogs as well as the stray dogs, as well as what is the difference between the lead level in kidneys in household dogs versus stray dogs, or what is the difference in lead levels in the livers of the dogs in household dogs versus stray dogs. And moving to the third one. Now it's a really different perspective. So here I'm just selecting one group, household dogs, and I'm trying to find who are the dogs who are having excess lead and who are the dogs who are having normal lead. And I want to find out who are the dogs who are anemic and who are the dogs who are not anemic. And I want to see whether there's a relationship between these two. So you can see all these questions are dealing with the lead concentrations and some adverse effects of lead. But based on how I have worded the research question, the output, the result that I want is different. So therefore, that is why I'm telling that the consideration of the statistics during your research should begin from the beginning where you are going to start with your research question. So once you design your research question, so you have to think how to answer your research question. This answering of your research question is based on the results. So you have to think, you have to articulate the possible results of this research. So you have to think twice. You have to think that whether these results will answer my research question. So then in that point, you are going to select, okay, if I want to find the answer to my research question, this is the statistical test that I have to be considered. And based on that, you have to go to the designing of your research based on the methodology. So what
Madam, we can't hear you. You muted.
Sugat, maybe she disconnected already.
Yes, she disconnected, no?
Maybe some internet connection failure, isn't it?
Yes, better to call her, no? Contact her and inform.
Professor Neil?
Yes, I think her connection disconnected.
Dr. Jas, she's having an internet, but maybe some reason actually she's already disconnected. She's trying to reconnect now.
So is it all right if I start from here, or did I miss this slide as well?
Can you go back to the previous slide, please?
This one?
Yes, I think so.
Okay, all right. I was talking when to select the correct statistical test. So with the basis of the questions that discussed, I think so we have to consider about the selection of statistical test from the beginning of designing your research. So once you identify your research question, you have to think how you're going to answer to your research question. And based on that, you have to articulate the possible results. And so this articulation of possible results, you have to think whether my results are going to answer to the research question. And based on that, you have to decide, okay, what are the statistical tests that I have to be included in my research? And the designing of the study, including the methodology and selection of what type of data to be collected and everything, goes after selection of the correct statistical test. So with that, I'm going to move to discuss the factors influence the statistical test selection. So most of these things are kind of theoretical factors. If you look at the books, okay, they are telling, okay, these are the factors that you have to consider. But so I will go through the list. So first you have to think about the number of variables and the type of data, distribution of data, and what about the outcome, whether is it a paired outcome or unpaired one. And most important fact that I decide is the aim and objective of the study. That again comes with the research question. So you have to think about, okay, this is my research question, and based on that, this is the results that I want. And based on that, you have to select your test, and to strengthen that test and to decide your methodology, you have to consider these factors that we are going to specifically talk about each of these factors. So number of variables, variable is the characteristic that you are going to look at during your research. So there can be 1, 2, 3, or many. And type of data. So all the data that we collect can be categorized into 4 main types of data. So categorical, ordinal, interval, or ratio. Categorical data means there can be different categories, but there's no relation in between. Something like gender, okay, male and female. So you can't decide which one is the first one and which one comes second. Or maybe the
Excuse
factors.
me, Dr. Dinesha. Excuse me.
Yes.
May I request everybody can mute your microphones? We can hear some background noises, please. To all, could you all mute your microphones? Thank you. Right, now you can go ahead.
Yes, sir. Right. So when we're talking about the type of data, so first group, categorical data. So categorical data means there are different categories, but there's no relation in between. Something like with gender. So what comes first, male or female? We can't decide. The blood groups. What comes first? We can't decide. There's no relationship between each of these groups. They're independent. So this kind of data, we consider it as categorical data. And the second type is ordinal data. So when thinking about ordinal data, we are thinking about some categories that can be arranged in an order. But The problem is the gap between these categories can be equal or might not be. We can't think about the gap. So it is something like when you talk about disease severity, we will talk, okay, mild disease, moderate disease, severe disease. So what is the gap between mild disease versus moderate? And what is the difference between severe to moderate? So it might be equal, might not. Or if you consider about a scale to assess the pain, so is it scale number 1 and scale number 2 versus scale number 3 versus 4? Is that gap similar for everybody? We can't make sure. So in that case, those data can be considered as ordinal data. And then comes the interval data. So interval scale means there is an order. You can keep them in an order. And the gap between each two parts is similar. So like with the time, 1 to 2 hour means just 60 minutes. 2 to 3 is 60 minutes. So the gap is same, but there is no absolute zero. When we talk about a zero, that really doesn't mean that there is absence of that thing, that factor that we are considering. So if we think, okay, zero time, what is the time you are indicating? Is it 12 midnight or 12 noon? What is it? Or zero temperature, 0 Celsius. It is not, it doesn't mean that there is no temperature. 0 Celsius stands for some level of temperature. So therefore, such data, you have to categorize them as interval data, interval scales. And the last group is ratio, where the numbers can be organized in an order, and the gap between them are same, and there can be a zero, as well as that zero means the scale, the factor that we consider is absent. So 0 centimeters is no length. 0 kilograms means no weight. So this 0 has a meaning, and that meaning is related to absence of the factor that we are talking. So that kind of data we can include it as ratio scale. So I'm again telling, so this sounds a little theoretical, but having a brief idea about these things will help you to identify the correct test. And these categories can be classified according to different forms as quantitative or qualitative. Some categorize this as discrete and continuous. But as I believe, so this selection of statistical test is done at the beginning, and then based on the test that you select, you can manipulate what is the type of data that you want. One example, you may think, okay, I'm going to take an interval data related to temperature, which is the interval scale, but I want to check it, taking it as 2 groups. So then you can convert that into a categorical data. You can tell, okay, I'm thinking about this time to this time, or this temperature to this temperature, and from there onwards to next temperature. So you are making 2 groups. So now it is not interval scale. Now it is ordinal scale. Or you can convert the ratio into categorical. Think about money. Okay, so no money is 0. So therefore, money is something that you can consider as ratio scale. But if you want to categorize it, okay, so from 0 to 5,000 income, 5,000 to 10,000 income, 10,000 to 12,000 income. So you're categorizing them, but there can be order, there can be no order. So there you're converting them into a categorical or ordinal data. So you can manipulate the data as you want once you decide the statistical test. And the second thing that you have to consider is the distribution of data. So distribution of data means the pattern, how the data is distributed, spread out in our sample. So with related to distribution of data, there are again so many things that we have to consider: central tendency, variability of spread, shape, and the outliers. I'm not going to talk about all these factors because the time is limiting. But when you look at the data, so one thing that you have to identify is how am I going to identify whether this distribution is normal or not? So it is easy. There are so many statistical tests that you can use. You can use histograms, which is a type of graph that I have shown here. So you can see, so in histogram, you are tabulating them based on what is the frequency of each number that you have. How many 2s you have, how many 5s you have, how many 10s you have. So based on that, you draw the graph and you get this graph called histogram. And you can get Q and Q plot. So this Q plot is you're plotting your observed value against the expected data. So if that is same, it should follow the line that is here. But if this sample, if the data is scattered around the line symmetrically, you can tell, yes, it is basically showing a normal distribution of data. Or you may go for this box plots. So again, you can see when you draw this box plot, these three box plots are different to each other. So they are telling, okay, this black line in the middle of this blue box is standing for the median. So you can see the two parts of the sample, is it divided symmetrically or asymmetrically? So that if it is asymmetrical, that means it sounds like it's not a normal distributed data. And you can look at the outliers. In the box plot, they have marked outliers here. One outlier here and extreme outliers here. So you can get an idea about the outliers from the sample. Are they really contributing to this, or are there something exceptional that can affect our result? So these kind of data can be taken easily from this type of graphs, which can be designed using software. And moreover, there are some statistical tests that you all can use as well. Shapiro-Wilks test and this Kolmogorov test. These tests are two examples where you can use them to check for the normal distribution. This test you can use when the sample size is below 50, and if it is more than that, you have to go for the next one. And you have to remember that when interpreting, here we are looking that this sample is not normally distributed. We are assuming that the sample is distributed, and we are checking whether it is not normally distributed. So therefore, the significance that we expect here is something more than 0.05. So if the p-value comes more than 0.05, we consider it is normally distributed, whereas if it is below 0.05, we consider that it is not normally distributed. So based on the distribution of the data, we can categorize our data into two groups. One thing, parametric normal distributed and skewed distribution. This is the normal distribution. If the data is normally distributed, we have to consider parametric test as our statistical test. If the data is not normally distributed, then we have to go for non-parametric tests. So what is the difference? If you can see in a normal distributed data, usually the mean, median, mode, everything is at one place. But if you look at this, you can see in non-parametric data, the mean can be somewhere else other than from the median. So median is the data which divide our sample into two halves. It is the 50% of our sample. This is the midpoint, median. So the mean is going maybe towards right side or left side from the median. So that means that this is not normally distributing. So if we are using a statistical test to compare means, knowing whether it is a normal distributed or not is important, because if it is normal distributed, yeah, we are considering about this type of pattern and we are comparing this data. But if we use a non-parametric, if you use a parametric test for not normally distributed data, we are trying to compare some place like this, not this, where the most data is towards this part. So we are missing the most frequent part and we are going for some exception when we try to compare means using parametric test for a sample where there is no normal distribution. So that is why identifying this pattern is very much important, and based on that you have to make sure if it is normal distribution, you have to go for parametric test. If it is not normal distribution, you have to go for non-parametric test. And one another important point, when you're dealing with not normally distributed data, the meaning that you can have by looking at its mean is very limited. But rather than mean, if you look at the median, it will give a more valuable information about that sample. So with related to not normal distributed data, we are interested about knowing the median. But with normal distributed data, we are interested to know about the mean. So that is how you decide the type of test based on the data type. The next factor that you have to consider is about the outcome, whether it is paired or unpaired. So paired means that there is a relationship between two groups that you take. Maybe the same group prior to preparation and after preparation. Or maybe there is some relationship like sibling tests or twin assessments, or maybe parents and daughters or children assessment. So some kind of relationship is there between the two groups. So that means the two groups are paired. So then we have to go for paired assessments. But if the categories are not paired, they are independent of each other. These are the categories in X group and these are the categories in Y group. They are completely different. So they are unpaired. So then we have to go for the statistical tests that are suitable to assess unpaired samples. So this is another factor that you have to consider when selecting the statistical test. And then, so we discuss about all the factors that we discussed, the number of variables, type of data, distribution of data, and the outcome. But as I mentioned earlier, the most important factor that I consider is having an idea about the aim and objective of the study based on that, the type of study design that you're going to do. That should be the most important factor which influence the selection of the statistical test. So with that, I'm going to start a brief discussion on different statistical tests. So when talking about statistical tests, we can divide them into two groups, descriptive statistics and inferential statistics. Descriptive statistics deal with describing the sample that you have. You select a sample and you're going to describe, okay, what is the mean of my sample? What is the median? What is the mode? What is the distribution? What is the maximum value? What is the minimum value? You are just describing the factors, the data that you took from your sample, but you can't give any conclusion or you can't come to any prediction with this description. And inferential statistics is where you are going to use your results to apply that to the population. So the purpose of doing the research is when you get a research question, we'll think about the first one. So you want to decide whether there is a relationship between the lead concentration in the livers of the dogs, in domestic dogs, with the anemia occurrence. So you can't go and check all the domestic dogs that are there in Kandy district. It is not possible. So therefore, you select a small population and you check it and you take the data and you analyze it and you find a result. So you try to implicate that data to the population. So for that purpose, you have to use this inferential statistics. So I'm basically trying to focus on inferential statistics today. And when interpreting these inferential statistics, we are dealing with this p-value. So if p-value is below 0.05, we consider it significant. So it can go beyond that, 0.01, 0.001. So that says so how much it goes towards zero. So if it is going towards zero, that means that is significantly different. The difference that you observe is statistically significant. But if it is moving towards 1, above 0.05, 0.06, 0.15, going towards number 1, so that indicate that this difference that you observe is not something that is statistically significant. So this is how we use our p-value to interpret all the inferential statistics that we are going to discuss. I'm going to talk a little bit about Pearson correlation and Spearman's correlation, t-test, ANOVA, and non-parametric test, chi-square test, risk ratios and odds ratios, and regression analysis. So I'm not going to talk about each of these tests, like how to do it and when to do it kind of discussion, but I thought maybe I can try to show the application of these tests. So first to talk about the correlation. So I do have a question. I want to see whether the urine protein levels is changing together with the serum creatinine levels in domestic dogs. So what I want to look here, so I want to look at the urine protein levels and I want to look at the serum creatinine level. So I am basically trying to change the serum creatinine levels and I want to see together with that, is there a change that happened to urine protein levels? So the factor that I'm going to change is serum creatinine level. So in that sense, that is the independent variable. The serum creatinine is not going to depend on anything. It is the independent variable. We do have the power over that factor. We are going to manipulate it as we want. We are not letting it to change based on other factors. So that is the independent variable. So here serum creatinine is the independent variable, and we are going to see when the serum creatinine levels are changing, is there a change that happens to urine protein levels? So we expect that the urine protein levels will change with the change in the serum creatinine levels. So that means the urine protein level is going to be the dependent factor, the dependent variable. So it is depending on the serum creatinine level. It is changing with the change in serum creatinine level. So you have the independent variable and the dependent variable. And now you have to think, what do you want to do? So you want to see whether the urine protein levels are changing with the change in serum creatinine level. So is there a relationship between these? When one goes up, can you say that other one is also going up? Or when one goes down, does it say that other one also goes down? Or when one goes up, the other one goes down? What is the relationship between these two factors? So that is what we want to see. In other words, we want to see the correlation between the two factors. So we are interested to know, is it changing? What is the direction? When one goes up, is the other one going up or down? So what is the direction? And also, what is the strength? Is it like when one point from serum creatinine goes up, 1 point in protein goes up, and another point goes up, another point goes up? Is it like that? Or when change with 10 points in serum creatinine, 1 point in urine protein is changing. So what is the strength of this linear relationship? We want to know both these factors. So when you're interested to know about the correlation or the relationship between two factors, the type of statistical test of interest is the tests that are there to check for the correlation. There we do have two tests, Pearson's correlation and the Spearman correlation test. So the difference in selection is based on the normal distribution of the data. So Pearson's correlation, we discussed based on the type, the variation, the type of distribution of data, we may categorize them as non-normal distributed or not normal distributed. So if it is a normally distributed, we are going to go for parametric test. So Pearson's correlation is a parametric test. So if the data is showing normal distribution, we can go for Pearson's correlation. And therefore, it's basically dealing with interval scales or ratio scales. That means where we are having continuous data, something like temperature or something like height, weight. So those kind of data can be included in Pearson's correlation. Whereas Spearman's correlation is dealing with data with not normal distribution. So it is a non-parametric test that you can use. And also, Spearman's correlation can be used in situations where one data type is continuous and the other is categorical with some ordinal or nominal scale. So with ordinal scale, we discussed that there is some order, but you can't make sure that they are following some basis to have that order. So they are just maintaining an order. So when you want to compare that kind of data with the interval or ratio scale, something like, okay, the severity of the disease based on the temperature of the environment. So temperature of the environment is the interval scale. The severity of the disease, mild, moderate, severe. So that is the ordinary scale. So if you want to compare these two things, then you have to select the Spearman correlation as the statistical test of choice. So you can do this test using whatever the software that you want. So I'm not going to demonstrate to how to do these statistical tests using different softwares, because I suppose that we can't be confined to one statistical software. There are so many softwares that are available. You can use whatever the software that you want based on your preference. And if you're interested, there are so many YouTube videos, online tutorials where you can learn how to do these tests easily. The most difficult part is identifying how to select these tests, what tests to be done. So that is what I'm basically talking about today. And then the second part is, once you get the results, how to apply that. So that is why I just wanted to show you this. So this is a result that you will get after doing Pearson's correlation. So you can see they are showing, okay, what is the association between the two groups? One group is height and the distance that you jump. So what is the relationship between these two? So these two squares are same. So this 706 is the Pearson correlation value. And you can see that it is just 0.7. It is not showing minus mark. So that means this is demonstrating a positive correlation. So the correlation may vary from -1 coming to 0 to +1. So if it is 0, there is no relationship. If it is a perfectly negative linear relationship, like with drop of 1 point in serum creatinine level, there is 1 point drop of urine protein level. With 2 points drop in serum creatinine level, 2 point drop in urine protein level. So likewise, if it is perfectly following a negative linear relationship, the correlation comes as -1. And if it follows perfectly positive linear relationship, like with 1 point increment in serum creatinine, 1 point increment in urinary protein, 2 point increment in serum creatinine, 2 point increment in urinary protein. So in that scenario, there is a perfectly positive linear relationship. So in that point, the Pearson correlation will come as +1. So we usually do not, the plus mark is not indicated in the test result, but if there is minus relationship, the minus mark will be indicated here. So here it says 0.706. So this says that this is a positive correlation that is there. And based on this value, the Pearson correlation value, we can get an idea about the strength of the relationship. For that, we can use this data. So if the Pearson correlation is between 0.1 to 0.3, it says it's kind of a very weak, small correlation that is there. If this Pearson correlation value comes between 0.3 to 0.5, the moderate correlation is there. If this is above 0.5, it is a strong correlation that is there. So in that sense, this is 0.7, which is above 0.5. So this is a very strong correlation that is demonstrated. So strong positive correlation is demonstrated between these two factors with the statistical significance of p-value below 0.005. So you can see this significance is mentioned here. So this is the p-value. So this is the data that we can take out using this. So if you look at this one, you can see this minus value. So this says it is a negative correlation that was observed. Still, it is statistically significant because it is below 0.05. So here they are telling, okay, so there is a negative weak correlation because it is between 0.1 to 0.2, which is statistically significant between these two factors. So that is how you come to a conclusion using results that you get for correlation analysis tests. Next, we'll discuss about how we can compare the means. Again, I try to take another example. So I was interested to compare urine protein to creatinine ratio of healthy domestic dogs and the dogs working for police. So now I do have two groups of dogs, domestic dogs and the dogs that are at the police. So I want to check whether the urine protein to creatinine ratio is same in both two groups. So we are having two groups. We are trying to compare the values between the two groups. So if we are having 10 domestic dogs and 10 police dogs, okay, we can assess all 20 and you can compare, okay, so these are the values for here, these are the values here. If they are same, yeah, we can consider if they are same. If they're completely different, we can say, oh, yeah, they are not same. But that doesn't sound very statistically indicated. So therefore, we have to select what is the type of statistical test that we can use in this kind of scenario. So now what are the factors that we have to consider in this case? So first thing you have to think, okay, what are you going to compare? It is the mean that I'm going to compare. So I'm saying it mean, assuming that this protein to creatinine ratio will have a normal distribution. So based on that, I'm thinking, okay, so I'm going to compare the means between these two groups. So then, therefore, I'm going to look at this interval or ratio scale. And then, because so we are going to look at, or the data that you're going to take is, okay, you're going to take the dog, you're going to measure the serum creatinine to protein ratio, you enter that data. Yeah, I think you all can hear me. So we can decide whether this whether the dog is domestic or at the police. So you can mark it. If it is domestic, you mark it as 1. If it is police, you mark it as 2. So you do have 2 data sets. One thing is the mean, the creatinine to protein ratio measured in that particular dog, and whether the dog is a domestic one or a kennel division belonging to police. So based on that, so you are going to decide from these 2 data, which one is the dependent variable. So you're assuming that serum protein to creatinine ratio is going to change. So that is the dependent variable. And you're going to compare this in 2 groups of dogs. So these 2 groups are the independent variables. The selection of these 2 groups is something done by yourself. You're not doing that because of the influence of any other factors. You're deciding and you're selecting that. So that is independent. That fact is not biased or depending on anything else. So selection of these T groups are independent. And once you select that independent groups, then you have to go for dependent variable. So you're checking how the mean levels are changing, how the serum creatinine to protein ratio is changing. So that is changing based on the type of group. So that is depending on the group. So that is the dependent variable. And the next factor that you have to consider is how many groups are there to be compared. Is it that you are going to take one sample and compare it with the sample that you expect to see in the whole population? That you may think, okay, the standard protein to creatinine ratio is this. So I'm checking whether these domestic dogs are having that, the mean value is tallying with that, with the mean value in the domestic dogs are within that reference range or not. Or you're going to compare the 2 groups, or there can be more than 2 samples sometimes. So based on that, the type of statistical test that you're going to use is going to change. And also, the test will be affected based on the distribution of the data. As I mentioned earlier, here I'm assuming that this is showing a normal distribution. That's why I consider a parametric test. But if you think that it is not normally distributed, then you have to go for non-parametric test. Okay, so based on these factors, there can be several different statistical tests that we can use. So in a case where you're going to take a sample and you're going to compare the results of this sample with your reference range. So you're just having one value and you're taking that value and comparing it with the reference range that you expect. So if the data of your sample is showing normal distribution, then you can use one sample t-test. If the data is not normally distributed, you can use non-parametric tests such as sign test or Wilcoxon sign rank test. And if you're comparing 2 independent groups, as with the case that we discussed earlier, we are comparing domestic dogs with the dogs who are there in the police. So we are comparing one factor, serum creatinine to protein ratio, so that we are comparing in 2 independent groups. There is no overlap between these 2 groups. So in such situations, if we expect the data to be normally distributed, the parametric test of choice is the independent t-test. And if it is not normal distributed data, you have to go for a non-parametric test. So you can select Mann-Whitney U-test. And the other instance is that you are looking for the same group twice. So just imagine, so you select one group of dogs and you give a vaccine to that, And then after several times, you take one group of drug and you check the protein to creatinine ratio, and then you give a vaccination or a drug. And then after 1 month, again, you check for protein creatinine ratio. And you are checking whether the ratio had changed with the influence of that vaccination or the drug that you have injected. So in that case, you are taking the same population in 2 instances. So there, if you expect the data to be normally distributed, you are selecting paired t-test. If it is not normally distributed, you can go for Wilcoxon signed rank test. So again, I'm telling, it's difficult to memorize these things, but if you have an idea, okay, this is the expected result that I want to compare the means, then you can come to this table and look at the data you have, and you can try to match with these factors, and you can identify easily what is the test that you want to do. So that is what is expected. So again, I'm going to look at how these results can be interpreted briefly. So talking about one sample statistics, I told you that one sample t-test can be used to compare the average value, the mean value that you got from your sample with the reference range. So here you have to, in this test, you have to mention what is the reference range. So here they are comparing some results with the test value. So the test value is 58. The normal range that you expect is 58. So you are checking whether your result, the sample mean that you got, is same as what was expected. Is it same as 58? So then when you perform this test, you will get a p-value. So by looking at that, this is the p-value. So by looking at that, you can say whether it is statistically significant or not. If it is below 0.05, it is significant. If it is above 0.05, it is not statistically significant. And going further, you can tell what is the difference between the 2 groups. With related to this, you can see that there is a column saying mean difference. So they are saying, okay, so in the group that we analyzed, there is a mean difference of 4.7 with the confident interval of 1.8 to 7.6. So you are telling that there is a statistically significant difference in the mean value of your sample from the reference data, from the reference range. And that difference was because there is a mean difference of 4.7 point with the confident interval of 1.8 to 7.6 range. So this confident interval range is that we use this when presenting the data. That means 95% confident interval range means if you are going to perform the same tests in different samples in this population, you are 95% sure that the mean difference that you get will fall within this range. In this sample, the mean difference was 4.7. And if you're going to repeat this in the population among different groups, you are 95% sure that this mean difference will be somewhere between 1.87 to 7.60. So that is what is meant by this data. So that is what you can gain by looking at the results from this one sample t-test. This is independent sample t-test. So we use this independent sample t-test to compare 2 independent groups. So as the question that we discussed earlier, we want to compare the serum creatinine to protein ratio among the domestic dogs and the dogs that are there in the poly. So 2 groups are there. You are going to compare the mean serum creatinine to protein ratio among these 2 groups, comparing between 2 groups. So then when you get the results, so you get the mean values for 2 groups, and the results will show what is this level of significance. So this is the p-value. So you can see the p-value comes as 0.1. So it is more than 0.05. So that means this relationship is not statistically significant. So by looking at the results, you can say whether it is statistically significant or not. And again, you can tell what is the level of difference that is there. Again, here is a column saying mean difference. And you can see that it has a minus mark. So minus mark says that it is not a positive thing that they're showing. The difference is something negative. So when you compare no dogs with the people who are owning the dogs, the frisbee throwing distance is showing that the people who are owning the dogs has a lesser one than the no dogs one. So it's showing a negative relationship. So the negative association was demonstrated with this. So in that case, you can get some idea about what is the degree of difference with these results as well, same as with the previous one. And then there's another type of t-test, which is paired t-test. So we discussed that the paired t-test can be used when you're analyzing the same group at 2 points. You check something, you give a drug, and you check the same thing again after some time. And you check whether there's a difference that had occurred in the same group. So you're looking at this data. So again, you will get the two means. Okay, this is before and this is after. And then you get the correlation in addition to the comparison of means. So this is some additional result that is given with paired t-test. So we discussed about the correlation analysis previously. So it is the same correlation that they demonstrate. So the significance is mentioned. So by looking at that, you can say, yes, there is a positive correlation that is there. So strong positive correlation is there because it is 0.9. And the p-value is 0.00. So that means it is below 0.005. So strong positive correlation, which is statistically significant, is observed between the two factors. But our idea is to compare the means. So this table demonstrates the comparison of means. So here you can see you get the mean value, the average mean value, and then here the confidence level, and then here the p-value. So by looking at the p-value, you can say whether it is statistically significant or not. And then you can say what is the difference. Again, what is the difference before and after? So you have compared before first and then after. So the difference between the means from before and after is 0.7 with the confidence interval of -1.4 to 2.8. So you can see this confidence interval is going beyond 0. So that gives us an idea that this kind of confidence interval shows that this relationship is not that statistically significant. So this is not a very strong data that you can get because the confidence interval is moving beyond 0. So application of the same thing, like I told earlier that the meaning of this confidence level is that you are telling, okay, if you check random samples in the population and you perform the same test, this much difference can be observed in all the groups. But when the point is going beyond 0, you are not sure about that application. So that is not a very strong data in that sense. So that is how you interpret the results that you get with related to mean comparison for one sample t-test, independent t-test, and paired t-test. So what are the tests that you can use if you are going to compare more than two groups? So up to here, we discussed either comparing two groups, either maybe one sample with the reference range or two independent groups or the same group at 2 points. So always there had been two means that you're going to compare. But if you're having more than two means with a question like this, so you want to compare the mean positive frequencies of Q fever in farm animals in 5 regions. So assume that there is a way that you can get the frequency, how within the last 2-3 months, what is the frequency of having Q fever in the farm animals in 5 regions. So you have 5 groups, A, B, C, D, E. So you want to see in these 5 regions, the occurrence of this Q fever is same or not. So you're going to take the region A, and you're going to check all the animals that are there, and you take the incidence and you get the mean value. So you have the mean value for region A. You do same for B. You do same for C. You do same for D. So you're having 4 or 5 mean values. Now you want to compare all these things together. So then in such instances, again, if you expect this data to have normal distribution, you can go for a parametric test that is one-way ANOVA. And if you're expecting that there will be not normal distribution data, so you have to go for non-parametric test, which is Kruskal-Wallis test. And if you're going to repeat the same assessment again, so you check for the mean positive frequencies of Q fever in 5 regions, and you're going to give a drug, and then after 3 months again you're going to check the frequency. So now you want to compare whether there had been a difference in the means between all these groups at 2 points. So in that case, again, if it is following the normal distribution, you can use a parametric test, which is repeated measured ANOVA. If it is showing not normal distribution, you have to go for non-parametric test, which is Friedman test. So I'm here just showing how you get the results from ANOVA test, which is the parametric assessment, one-way ANOVA test. So when you go for one-way ANOVA test, this is the table that you're going to get. So they're telling, okay, there is a statistical significance. The significance is mentioned. So there is statistical significance between the groups or within the groups, but they can't specify what exactly is that difference which is contributing to this significance. So maybe it is a difference between A and B, but not with C and D or A and D or anything. It's just because that there is a strong significant difference between A and E that we get it positive. Or maybe we are having a difference between A and B as well as A and C, but not between A and D or B and C. So different within the groups as well as between the groups, the associations can vary. So due to one of these associations that we are getting this positive, statistically significant positive result. But just by doing this ANOVA test, you can't say what is the exact group that contributed to this significant. If you want to assess that, then there is another step that you have to perform, which you call as post hoc test. So it is easy in this statistical softwares. Again, when you're performing the ANOVA test, just mentioning that you want to post hoc test and you select the test that name that you want. So you get the post hoc test results as well. So there they show comparison between the groups. So here you can see they have compared beginners with intermediate and beginners with advanced. And they're showing for beginners with intermediate, the significance level is 0.46. And for beginners and advanced, it is 0.34. And if you look at this intermediate and advanced, it is 9.8. So statistical significance is there observed between beginners and intermediate as well as beginners and advanced, but not between intermediates and advanced. So such kind of comparison you can give following this post hoc test. So that is about comparison of mean. So up to now, up to this point, we discussed what are the tests that we can use to assess the correlation, and then what are the tests that we can use to compare the means. Then I'm going to talk what are the tests that we can use to check the association between variables. So here I'm basically talking about categorical variables. For earlier test, we basically used continuous ones, mostly interval and interval data and ratio scales we used. But here what we are using, categorical ones and ordinal ones. So again, a question. Is there an association between antimicrobial prescription behavior among young veterinary practitioners and the gender? So if there is a way that we can assess, okay, so the antimicrobial prescribing behavior is good and bad versus male practitioners versus female practitioners. Is there association between these two? So now, first we have to identify, okay, what is the outcome that you want? What are you looking at? So you want to check whether antimicrobial prescribing pattern is changing between genders. So selection of genders is something you have done. You can't manipulate it. That is already there. So It is the factor that you're changing. It can't get affected by anything else. So in that sense, gender is independent. And based on this independent factor, gender, you're thinking that the antimicrobial prescription behavior can change. So this antimicrobial prescription behavior is the dependent variable here. So identifying dependent and independent variable is important because based on that, you're going to tabulate these two factors. When you are selecting these data for analysis, the software will ask, okay, what is the dependent variable that you want? What is the independent variable that you want? So that is why you have to think about your research question and always try to identify what is the dependent variable and what is the independent variable. And then, so the type of data that you're going to deal with, you're dealing with ordinal or nominal data. And then, what is the test that you can use? So for this kind of analysis, you can use chi-square test. So chi-square test can be used as 2x2 table. So here it is, if you are telling antimicrobial prescription behavior, good, bad, male, gender, male, female. So it is 2x2 table that you're going to get. But it can go as 2x3 table, 3x3 table, or even further. As far as the factors that we have to, there are several factors that you have to make sure that are fulfilled. So based on that, we can make sure that chi-square can be applied in these kind of situations. So what are the factors that we have to think in these situations? So here you can see it is again a 2x2 table that they have used. 1, 2, 1, 2. So here, this is the result, the chi-square result that you get. So this is the p-value that we want. So here the p-value comes as 0.23. So that means more than 0.05. So it is not statistically significant. And one important thing that you have to consider when interpreting chi-square results is this. So there is a minimum expected count for these values in the chi-square test. So they expect that this each point, each cell should have a count, they should not be less than 5. The count should always more than 5. So here the minimum expected count is 931.37. So you can see that all these 4 cells are having counts above that, only 1 is below that. So they're telling if 2 cells are going beyond that. If it says 25% is having expected count less than 5, more than 25% is having expected count less than 5, in that instances, interpretation of this chi-square test is wrong. So here you can see, this says 2 cells have expected count less than 5, but still it is at 10% level, but it is telling that two cells are not having expected count. So if you look at this, you can see that here we have 3, here we have 4. So then in this kind of data, the results that we are going to get are not that strong enough. So application is strong when we are meeting this criteria, but not this. So when you are interpreting, this is the p-value that you're going to consider, and you have to consider about these factors, and you have to interpret the chi-square test. So as I told you, you can use it for 2x2. Here you can see they're using it for a large table, but as far as these values were higher, you can use it, no problem. Okay, so then the next part, how to compare, how to analyze exposure versus outcome. So up to now, we discussed how to find the relationship, how to compare the means, how to compare the categorical variables. Now we are thinking how to get an idea about exposure versus outcome. So again, a question. Low lymphocytic count in dogs is associated with viral infection. So the question is whether there is an association between low lymphocytic count in dogs with the viral infection. So now again, you have to think about the parameters. What is the parameter that you are going to manipulate? So you want to see when the white cell count is changing, whether the incidence of viral infection is changing. The factor that you are going to change is the lymphocytic count in dogs. So that is the independent variable. And the outcome is whether you're having viral infection or not. So that is the dependent variable. So that factor is going to change based on the lymphocytic count of the dog. That is what you expect. So you expect it to change with another factor. So that is depending on that. So that is the dependent variable. So in this case, both should be either yes or no situation or binary data. So there should be only two categories when you are looking for exposure outcome. So this kind of table you can build up using this data. So with related lymphocytic count, you are expecting to have low or normal. And some of the dogs who are having low counts will have viral infection, some might not. And some of the dogs with normal lymphocytic count will get viral infection and some might not. So you can get the data like this. So then, based on what you want, you can manipulate this data. So think, your question is, what is the risk for a dog with low lymphocytic count to get a viral infection versus the risk for a dog with normal lymphocytic count to get a viral infection? So now you are interested to know, if you are having low lymphocytic count, what is your risk to get infected? Versus if you are having a normal lymphocytic count, what is the risk level that you can get infected? Is there a difference between this? If there is a difference, yes. So we have to be cautious about having low lymphocytic count. If there is no difference, of course, we don't have to worry. So in that point, so you want to check the risk for dog with low lymphocytic count to get an infection. So this is the risk for a dog with low lymphocytic count to have an infection. So if you want to get the probability of that, you have to, so A plus B are having low lymphocytic counts. So out of that, only A is having the infection. So that is the ratio to have infection when you're having low lymphocytic count. Then the next part is, what is the risk for a dog with normal lymphocytic count to develop the viral infection? So C and D are the dogs who are having normal lymphocytic count. And out of these two categories, only C developed viral infection. So out of C and C plus D, only C developed viral infection. So C divided by C plus D is the value where the dogs with normal lymphocytic count can get an infection. So risk ratio is the comparison between the ratio between these two factors. How much, what is the risk to get infection when you are having low? What is the risk to get infection when you are having normal? So you are comparing two incidents, two conditions of your independent variable. So that is what you deal with risk ratio. Now I'm changing the question. So now I'm interested to know how well the low lymphocytic count can predict the possibility of getting a viral infection. I don't want to know when you're having infection, when you're having low lymphocytic count, what is the possibility of getting viral infection? No. I want to know, how can I use this to predict the possibility of getting the viral infection? So in that sense, I want to know, so out of the dogs who are having viral infection, how many dogs are having low lymphocytic count? Out of the dogs who are not having viral infection, how many dogs are having low lymphocytic count? So out of the dogs who are having viral infection, but having low lymphocytic count. So that means A divided by C. Out of the dogs who are having no viral infection, how many of them are having low lymphocytic count? B divided by C. So if you get the ratio between these two, that is what you refer to as odds ratio. So this is risk ratio and odds ratio, the same thing that I explained. So risk ratios can be usually used to assess in cohort studies and also for retrospective studies. Retrospective studies is we are dragging the data, from the things that have occurred in the past. But when you are looking at a prospective data, or when you are doing a follow-up study, you are initially identifying the group and you are checking whether they are getting this or not. So in that scenario, it is better to go for odds ratios. For case control studies and prospective and follow-up studies, you can use odds ratios. So when interpreting odds ratios or risk ratios, again, there are three types of results that you may get. The result may come as 1. So 1 means there's no difference between the risk or odds between the groups that you compared. It could be more than 1. So that means there is increased risk or odds among the exposure than the unexposed. If it is below 1, that means there is no risk. The risk is decreased. So you can predict either. You can tell about increased risk as well as decreased risk with the results that you get for odds ratios and risk ratios. So when you are writing the results, this is how you're going to get. So this table, the wow table, these two tables shows the results that you got for risk ratio. So then the risk of having HIV by IV drug users is 9.3 times higher than the risk of having HIV by non-IV drug users. You just use this value. Again, you can indicate the 95% confident interval together with this as well. If you are looking for odds ratios, you're going to use this data. So you're going to tell the odds of survival by females is 0.1 time less with compared to the odds of the survival by male. So again, you can indicate the 95% confident interval. Last part. Another thing that we can do in statistical analysis is regression analysis. So I'm not going to talk in detail about regression analysis because it again is a very big topic. So regression analysis is dealing with a method of forming a predictive model to investigate the relationship between a dependent and independent variable. If you can remember, in the Pearson and Spearman correlation, we checked for the relationship between two categories. And imagine that you identify, okay, there is a positive relationship or there is a negative relationship. So you want to exactly know what is the type of relationship. Is it like X is increasing together with Y? Or with Y plus 0.57, X increase 1 point. So is that the association? Or you may have different kind of associations. So building up this kind of predictive model can be done using this regression analysis. Again, there are different types of regression analysis that are there. Linear regression, polynomial regression, logistic regression. I just put a few words just to introduce these concepts. So linear regression means it can be used when you assume that there is a linear relationship. So you can see here. So if you expect a linear relationship between the two factors, you are going to use linear regression. But if you are expecting not a linear relationship, then you can use something called polynomial regression. And in the cases where you are comparing categorical variable, you can see because categorical variables are not having the data in between. So it is difficult to build up a linear relationship between categorical data. In such situation, we use something called logistic regression. So these are the types of regressions that we can use in different situations. So building up these models are not that difficult. If you can identify when to use this, it's just a matter of going to your software and just going to the regression analysis part. So this type of results will be there. You will be getting a lot of tables which relate to this, and you have to look at a lot of factors when interpreting the regression models. And using these factors, you are going to build up an equation that you can use as a model to predict these things. So you are going to predict something using the age, weight, heart rate, and the gender. So they are telling, okay, age multiplied by this factor plus weight multiplied by this factor, heart rate multiplied by this factor, and the gender multiplied by this factor is equal to the variable that we are interested. So likewise, you are going to build up a model using this data. So I think I briefly discussed about all these statistical tests up to now. And the last part, what are the strategies for statistical test selection? So if you look at different places, there are so many flow diagrams that different people have built up, making it easy to find the required statistical test for you all. So based on the type of data, the distribution of data, whether they are paired or not, So you are going to consider the factors related to data and decide the test that you are interested. But moving from here, I'm going to propose this plan. So it's first, you have to consider your research question. So you have to think what is your research question is. And based on that, you have to decide what type of results will help to answer your research question. So is it an association that you want to look for, or a correlation, or you want to compare the means, or you want to check for the occurrence of risk, or you want to check the probability of happening something, or you want to build up a model to predict something. So based on what you want, you have to select the test. And with that, you have to go to that flowcharts that I mentioned, whatever, you can take them from different sources. So you can take a flowchart and you can just go and check, okay, so what type of data are they telling to use to get this test? So then based on that, you can decide your research. So that is the best way to follow in selecting the ideal statistical test for your research. I think that is the end. So basically, I try to discuss what is the relevance of including selecting statistical tests in the research and the factors influencing that, as well as a brief overview of different statistical tests and the strategies that we can follow for test selection. So I'm happy to answer if there are any questions.
Okay, madam, thank you very much for your very informative presentation done today. For now, this is open for your questions. Participants, if you have questions, actually you can raise your hand, or you can drop your question to the drop box anyway, and or you can unmute your mics and ask questions. Okay.
Dr. Sugat, before you have to say something before going for question and answers, Dr. Sugat? I think Dr. Sugat is.
Is he here now?
Yes, I'm here.
Yes. Yeah. You have something to say regarding Professor Indunil wanted to say something just before the question and answers. Am I right?
Yes. Professor Indunil, are you here now?
Yes. Yeah. Actually. Yeah. Thank you very much, Dr. Ijaz and the EXCO for accepting my proposal to have a few sessions related to this use of statistics to improve our studies, especially abstracts in proceedings. So, and Professor Alas and Dr. Sugat for arranging this. Actually, probably, I mean, we all understand that it is really difficult to give you all an understanding about statistics within 1 hour. And yeah, Dr. Dinesha gave a good try, and it is not easy at all. But don't worry, our goal is actually two things from the scientific committee this time. One, the first thing is that. For example, once you listen to this talk, if you are confident that if you have a kind of basic statistics knowledge, so just use the simple things in your research. For example, so it will add the kind of scientific meaning to the findings. So, for example, if you can simply, if you are basically doing a study based on maybe, I mean, doing something on incidences, for an example, maybe antibiotic residues in 2 animal products, for an example, or maybe you are going to compare 2 means of 2 groups, for an example. So, I mean, start with simple things and then try to do a kind of comparison, maybe a mean comparison, or maybe if it is maybe comparing percentages, maybe using chi-square. So if you are having kind of basic statistic knowledge, you can proceed to have kind of basic statistical comparison. So the other choice is that imagine you don't have any exposure to statistics. So our proposal here is to have kind of to get a statistician in to your study, and maybe of your choice. So maybe you have contacts with people who have, who are having statistical knowledge. So collaborate with them, get them in your study, and to have good statistical analysis. So we are about to start. We are about to start an abstract call. So there is no time to design a research and to conduct it. But for example, if you have data now, ideally, when we have, statistical, analysis, as Dr. Dinesha very correctly mentioned, you have to, you have to think about statistics at the very beginning, at the level of, experimental design. So, but now we propose that get a statistician in your research group, and then to have, give a try to have a kind of basic analysis and to improve your study and to improve the face of the abstract. So that is the goal. So we are planning to have another maybe 2 sessions, maybe one on abstract writing, and the final one we are going to show that using some of the previously published abstracts with the consent and with the permission of the previous authors, and or else some hypothetical situations using those abstract from the proceedings, and we will try to show you that how you can improve the findings by using kind of simple statistical applications. So we don't have a time to go into learn statistics and to have advanced statistical comparison. So this time the goal of the scientific committee, so we are going to start the abstract call very soon. We are going to have the first meeting on Tuesday. So we will decide there and we will suggest SLVA Exco. And then, so at this moment, our goal is to have a kind of improvement. If you don't have an idea about basic statistics, get a statistician into your group and discuss with him or herself, and then try to improve. So thank you very much for the time, Dr. Sugat and Professor Alas, and also Dr. Ijaz. Thank you very much. So we will have this continuous discussion until the end of this abstract call anyway. Thank you so much.
Thank you very much, Professor Indunil. Now, shall we start our Q&A session?
Okay, 3 comments are there. Dr. Udita Bandara, thank you for your very simple but very informative presentation. And Dr. Samara Sakkajamari, I don't know. Maybe
Dr. Kamalika.
Huh?
Dr. Kamalika, no?
No, that's a different. Kamalika is second or the third one, actually. That Sakkajamari. So maybe the pronunciation is correct. Thank you for your informative presentation. Dr. Kamalika asking a question. Thank you for your presentation. When testing correlation between continuous data, if the data is not normal distributed, how to select the test?
So there are 2 tests basically we discussed with related to correlation analysis. One thing is Pearson correlation and the Spearman's correlation. So Pearson correlation is the standard test that we can use if the data is normally distributed. and Spearman's correlation test. Spearman's correlation test is the test that we have to use if the data is not normally distributed. And the other instance that we can use this Spearman correlation test is if we are comparing, like even maybe like when we are comparing the two data, one can be continuous and one can be categorical. And in that instance, if the continuous, whether the continuous data is normally distributed or not, since we are incorporating a categorical one, definitely we have to go for the Spearman correlation. So Spearman correlation is the test that I would suggest in this instance.
Okay, thank you. So, as there are no other questions, Dr. Shall I ask some questions actually, the sake of other participants?
Yes, sure.
Yeah.
Go ahead.
Okay. So anyway, you mentioned that the paired and unpaired t-test. So sometimes actually we use paired t-test and unpaired t-test. Is that the thing you discussed actually?
There are different instances to use unpaired t-test is the same as what we discuss as independent t-test.
Okay, then paired t-test?
Paired t-test is different from unpaired one because paired one is, we use paired one when you're following the same group twice.
Okay.
With the time gap. But unpaired one is the same thing that we mean as independent t-test.
Okay, then that means when we test, I mean, compare two groups.
Two groups.
So if we want to compare two groups, actually you said we can use ANOVA. So there, you know, that the ANOVA test actually in the ANOVA test structure itself, built in, you know, t-test star, I mean, the different statistical tests are available. So sometimes actually we see, I mean, when we use some packages, you know, that there are some kind of different, the words are added to, I mean, before some test actually, especially this ANOVA, one-way ANOVA, two-way ANOVA. What's the meaning of this anyway?
One-way ANOVA test is, it implicates that, again, we are comparing the means, but at one instances. And the other tests are
one variable.
Yes, multiple variables. So we are like, it's same as what we did for unpaired t-test. In unpaired t-test, two different groups, two means. But when there are more than two different, we go for one-way ANOVA. And same as for the paired t-test, like if we want to repeat the same group again, and if we are having like more than two groups, and we are going to repeat all that 3 or 4 groups again with the same thing and assess the means and we compare, then we have to go for this two-way ANOVA, multiple ANOVA, such tests.
Okay, that means the one-way ANOVA is used when
mostly common.
Yeah, okay. So that means you mean that the one-way ANOVA is used for when there is one categorical
One instances.
Okay. Then two-way means more than one instance.
Yes.
Okay, understood. So then, you know that, I mean, when we are using, so there are a lot of, you know, that the things are, I mean, included there, like F ratios, you know, that post PLSDs, that means post hoc, I mean, the least significant difference. What are those anyway?
Sorry, sir, I did.
Yeah, when we are using, you know, ANOVA,
yes.
other things also come across there. So like F ratios, you know, that PLSDs, that means post hoc, you know, these significant differences and all these things.
That is because just the ANOVA table result gives only the idea whether there is a significant difference in between, either in between the groups or within the groups. It's not exactly saying whether the difference is in between the group or whether the difference is within the group. And if it is within the group, what are the exact groups that are having the difference? So if we want to go and check what is the exact point that is giving this difference. So we have to go for that list that Sir mentioned. And we have
Okay,
to...
that means when you run this, F ratios, we can see some kind of difference. Is that the meaning you said?
yes.
Yeah,
Like,
then,
again,
okay,
like
that
we can
means,
go for more specific analysis with the other parts.
okay. So that means there is at least, I mean, we have to run some kind of the test. That means like
Post-hoc test.
okay.
Want.
So to get to check, there is at least one or that significant difference there or not to proceed that one for further. Is that?
Yes.
Yeah,
Yes,
okay.
sir.
Okay. So then anyway, that that is there any the connection between this statistical analysis and the deciding the analysis of the sample size?
Designing the sample size, there are, we may say, sir, like, yes, there are some links because one few examples. Now, for most of the test, the accuracy of the data is always with the bigger sample size. Especially when we are using this chi-square test, and there are a few other tests. So if the sample size is small, then there is a limitation in using such test. Then we have to either go for some other special test, or if we want to use that particular test, we have to make sure the sample size is adequate so that test can be applied to this particular test that we select. That is one point. And the other point is we discussed two types of data, that normal distribution and not normal distribution. So there are some data anyway that we can't make sure that they will be normally distributed. But even for the usually normally distributed data, if we look at a small sample size, there is there's possibility that they may show a not normal distribution. So then eventually we do have to go for non-parametric test, which will reduce the power of our test. So if we want to go for parametric tests, which will have more power over the normally distributed data, so then to make sure that we are getting data at normal distribution range, we have to make sure that we are getting enough sample size. That is two possible associations that I could think with related to statistical tests and sample size calculations.
Okay, so as the final question, so sometimes actually that now that as Professor Indra said, sometimes actually some the groups, some researchers, they have already start without thinking about the prospective or the future, statistical analysis of their for their the proposed or whatever the projects anyway. So they have already already done a lot of things. So do you have any kind of what kind of advice you can give, as that sometimes actually some groups or some businesses they already have data. So what kind of advice to revisit their data or revisit or to give some kind of meaningful the value for that kind of data?
So the best way could have been to think about it earlier, but in a case that we are having data, like I think for a person who is listening for this type of statistical test for the first time, definitely they will find it difficult to take it, but maybe they can go back and think at least like what type of data do I have in my hand? Is it a categorical one? Is it an ordinal one? Like what kind of data is it? So based on that, and what is the research question, that why did I collect this data? So then they can, I think how can I link this data to my question? So sometimes, as I mentioned earlier as well, sir, like there is ways that sometimes the continuous data, we might make them categorical if we want. So you can go for a chi-square test and you can check the association. But initially, maybe you have collected a continuous ratio scale data. Like you have collected the temperature, or you have collected the mean protein ratio, protein values, or sodium levels, or something. But if you want to go for some kind of risk ratio assessment or ratio assessment, maybe you can categorize them. Okay, so I'm thinking normal versus low, or normal versus high. So I'm having two categories. So then you can manipulate it, and you can see by doing that whether you can match your data to the research question. So there will be some meaningful analysis that we can do.
Yeah, or maybe they can select more conservative methods, that simple methods, conservative, like one periodic corrections and, Turkey calm procedures, whatever the may be. It depends with the data that they have. Sometimes you can't give up, good value to the unplanned, research and unplanned data that they got due to the unplanned research anyway. So these are the questions from my side. I'll check the, Dropbox again. So there are, thanks for Kamalika. Dr. Kamalika actually said thanks for explanation. Then look at Dr. Scott said, dear madam, thank you very much for your informative presentation. Then Dr. Indru, thank you, Dr. Dinesha. And Disna Sirisena said, thank you, Dr. Dinesha. That's all. No, there is another one. This is very useful session. I suggest if you can continue analyzing data set with using statistical software. Thank you for organizers. From Dr. Kamalika, we will try to after we organize the proposed the requested webinars, then we will try to include this kind of session again. So thank you very much for your suggestions, questions, and appreciations, and all these things. These are from my side. Thank you, Madam Dinesha, for your informative and presentation. Actually, I completely satisfied with the. I understood the things completely, but maybe our job is to actually make others understand, make the young researchers understand. So thank you very much for your presentation again. And again, this is again back to the. I hand over this session back to Dr. Sugat. Thank you, Dr. Sugat.
Thank you, Professor. Thank you very much. On behalf of SLVA, I would like to invite Dr. Deshika, the Secretary of Sri Lanka Veterinary Association, to deliver the vote of thanks. Dear Dr. Deshika.
Thank you, Dr. Sudat. I think it's our duty to thank the resource person and the participants on behalf of Sri Lanka Veterinary Association. First and foremost, I wish to extend my sincere gratitude to the resource person, Dr. Dinesha Ambagaspitiya, Lecturer, Department of Biochemistry, University of Peradeniya, for your commitment to give us your valuable time to enhance and update the knowledge of our members. And I also would like to take this opportunity to thank Dr. Sugat and Professor Neil for organizing this wonderful event. And thank you all, our colleagues who participated in the event. I strongly believe that this attempt of Sri Lanka Veterinary Association is fruitful, and you have enhanced your knowledge on this topic. Also, I'm happy to announce that we are hoping to organize this kind of webinars throughout our tenure to enhance the knowledge and update our membership. Thank you very much on behalf of Sri Lanka Veterinary Association.
Thank you, Dr. Deshika. So shall we wind